Ta-da! Big garage door! So, exactly how did I make this? Stay tuned, watch this video, and I'm going to show you how this got built piece by piece. A lot of work, but you get exactly what you want.
That's right, exactly what you want. And that's really what this channel and this build series is about, is building exactly the camper that I want based on the drawings, the design that I wanted and I created, and also the chassis that I had built up into a four-wheel drive camper for me, and then building out the actual box, the camper box, from custom composite panels built to my specifications onto this chassis. And of course, that did mean also making a lot of big cuts into this camper, and including these garage door openings, which were the scariest of all for a whole lot of different reasons, but they've now been formed out, trimmed out, and now it's time to actually build the garage doors from custom composite panels I'm going to build up, and that's what I'm going to go over in this video. I'm going to show you how I did that. So stay tuned. So much coming up in this video and more. Today we're going to be making composite panels, my own composite panels, and I'm going to make these for the garage doors. We're going to go into that and we're going to do it. Do I know how to do this? No. We're going to figure it out. Let's go through it, make it happen. Okay. So if you remember back, gosh, probably like 30, 40, 50 videos ago, I cut some massive openings into each of the side walls in the back of my camper here, right? Those openings are for my large gear garage. It's so large so it can accommodate bikes, many bikes, basically about 6 bikes that can roll in, keep the rear tire on it. So that's really the best I can do to keep the bed height down. That means I need some really big garage doors. And I really wanted to buy these garage doors from somebody, but the reality is nobody has garage doors as big as I wanted. They're generally only get up to about 3 feet by 3 feet. My garage openings are about 40 inches by 40 inches, or a little bit more than that. And that's what I needed in order to accommodate the bikes I have. My bikes are about 40 to 44 inches tall with the rear wheel on. And so that's what I need to accommodate. So my garage opening is designed to accommodate that. But what I'm going to do is make my own composite panels. I couldn't find any composite panels that would mate up with the extrusions that I bought to go encapsulate the sides of the garage doors. And these are the only extrusions I could find that would accommodate this. So I had to work with that. So I'm going to have to make up my own panels and have to work with really materials that I can readily procure, which is unfortunately limited. So here's what I come up with as my plan to make this work. And I'm hoping it's going to work. Let's see. And you may ask, well, why am I not using my cutouts to just build my wall panels here, or the whole big cutout that I used to make this whole wall panel? There's a lot of reasons. One is, you can see these wall panels get really kind of beat up, and so there'd be a lot of trimming and cleaning up and stuff like that to make it really clean and neat. But also, these protrusions I was able to procure do not match up with these wall panels on the interior thickness here. And you know, I'd have to cut this thing in half, scrape some material out the middle, re-glue the foam back together, which is not going to be structurally sound. And so it just wouldn't be a good option. So hence why I didn't take that path. And hence why I'm taking the path that I am. First of all, composite panel is really just nothing but different materials, of course, all glued together in some fashion, right? There's many forms of that. Carbon fiber, fiberglass are good examples. And of course, the composite panels of the camper box, foam sandwiched between 2 sheets of fiberglass, one on the inside, one on the outside. Those can be of different thicknesses. As a matter of fact, I believe they are different thicknesses in this camper here, a little bit thicker on the outside for a little more durability and protection. You can see the garage door openings I have right here, right? They are big, no doubt about it. They are really, really large. And so I got to make doors that are going to fill in the space. And also, I went with a little bit of an odd shape here. And I went into some details on that before, but it's really to go over the bumper and get some additional bumper box space here, and then also accommodate the spare tire that goes up in here as well. And so that's why I got this cutout. It gives me more space in the gear garage. It maximizes my space on the bed platform above it, so that's comfortable, and maximize my space inside here for my bikes and other gear. It's going to go inside here. But I've got these really big garage doors. They're going to swing up, so I've got a really strong hinge. It's going to go back here. Actually, it's right here. And then I've got, of course, a frame I have to build in or glue in all the way around here. That's going to basically be my weather tight, have the seals and create my weather tightness, and also allow the garage door to basically not get pushed in. So what I've come up with to build these garage doors are sheets of fiberglass. It's the lightest, strongest thing I could procure in 4x8 sheets, and I really need that about that size because, again, I really need roughly 4x4 sheets. I could buy carbon fiber, but it was incredibly expensive. Same with Kevlar. Kevlar it's not as good a material for this for many reasons. Carbon fiber is as good a material as the fiberglass, but it's a very, very much just a minimal weight savings over the fiberglass in the same thickness. It does have quite a bit more torsional strength than the fiberglass does. Those are some benefits to it, but it is incredibly more expensive. Already these fiberglass sheets are very expensive, right? We're talking $300 to $600 each, depending on the thickness in a 4x8. So already they're expensive. Being that the camper itself is made of fiberglass, right? And so it's strong, it's durable, it's an appropriate material, it's outdoor rated, even though I'm going to paint these. And I can get all kinds of polyurethane adhesives to adhere to it. Now the question really comes down to is I know you can get polyurethane adhesives that are going to adhere to the fiberglass just fine. Are they going to adhere to my middle panel, my lightweight panel? This only weighs about 8 pounds or less for this whole 4x8 sheet. It's an R value of 10, but it is in 1.5 inches thick. And so the question is, will the polyurethane adhesives adhere to this aluminum, and will this aluminum sheathing that's on both sides of this sheet here, this rigid foam, actually stay adhered to the foam? I've done a couple little tests trying to peel it away, and I've not seen that happen. It seems like it's going to hold up well, and obviously it's not a perfect sheet. This is the best sheet I could find and get. It's got some wrinkles and stuff in it. That's very typical of this, but it's in good shape. It's got a slight bow to it. I'm going to work with that bow. Part of why I've got the panel set up here in the garage on a flat piece of concrete is so that when I glue these up, I'm not going to have this bow or ripples or something on it like I had set it up initially onto some sawhorses outside where I was initially going to do it. But of course, those sawhorses, you get tiny little ripples, and of course, the sawhorses don't cover the whole width and length of the sheet, and so you get these little bit of fall off or bowing that happens at the ends. And of course, once I glue that, it's going to be glued in that position. I can't really clamp it until I get the other sheet on, and then I can clamp it, but it's going to have those bows. And then when I cut the garage doors down out of this one single big sheet for each of the garage doors and cut them down from that, I'm going to have these little changes in the shape of that. It's not going to be a perfect flat plane. I want that. I want it to be a perfectly flat plane. And of course, I don't have the manufacturing processes or techniques or machinery to do that, and so this is my way of getting to the exact thickness I need, making up this composite panel exact thickness I need to fit in the extrusions I have that are going to build out these garage doors. What I've got to do now that I have these sheets cleaned up and vacuumed, rubbing alcohol, everything else, I'm going to spread out some polyurethane adhesive sealant, spread it out, like literally like smooth it out with a scraper across this whole entire panel, try to get all the way right up to edge, and then with help have another panel laid down right on top of this, and then basically repeat the same thing for the top sheet, which is going to be a little bit thinner thickness, so a little bit thicker on the outside, a little bit thinner on the inside. These are thicker than I wanted to go with, why they're so heavy. 3/16 and 1/8 is what I needed to add that with the 1.5 inch thick panel, which is, it's materials I can get and the thicknesses I can get, and so that will give me the thickness to fit within that extrusion. Hopefully the adhesive sealant doesn't add much thickness, otherwise it will not really fit. And I'm hoping this is going to be strong. I'm hoping it's going to be flat. Once I get the extrusions around the edges, it's going to be really strong. I don't think I'm going to have any peel away or anything like that. The adhesive I'm using has roughly between 400 and 600 pounds per square inch of tensile strength. Incredibly strong. It's good from -40 to 200-ish degrees Fahrenheit, plenty strong, and to handle the weather conditions. It's outdoor rated, it's waterproof, water resistant, all this stuff. Even though it's going to be sealed up with the extrusions and seals up, it's basically the same polyurethane adhesive sealant I've been using to not only build the camper box and all these extrusions around it, glue in the windows, also glue the cabinetry framing to the inside, and it is incredibly strong. Very little of it, and I can hang from it. And so I know it's going to be strong enough. The question is how is this whole process going to go? I think it's going to be tough, but I'm going to get going here. So make this happen. Here is the insulated panel, 1.5 inch foam, double-sided with aluminum. So I think we should have really good adherence with the adhesive I'm using in this fiberglass sheet, both 4x8 sheets. Fiberglass sheet in 3/16 on one side weighs 68 pounds, and this board here weighs 8 pounds, rounding up. Our insulation of almost 10. And so now I've got to clean this up. I just vacuumed it. This one's been cleaned. I got to clean this one as well, some rubbing alcohol.
And then it's time to glue it up, and I mean a lot of adhesive sealant. And so I first applied one whole entire big sausage tube, the 20-ounce tubes, and then a second one to go ahead and get this whole thing really well covered, smeared over, and then of course take the center core, which is the insulative core, 1.5 inches, and really compress that down. Remember, it's got a little bit of a bow into it. Really compress that down, then clean up that panel. Make sure the air panel before it goes on top of it is cleaned up. After smearing out all this adhesive sealant, you can see it kind of gets compressed a little bit as I bow it out, even though it's not moving between the two panels. And then take this other panel and go ahead and place on top of it. It is a bit flexible of a panel before the adhesive sealant gets placed onto it. But once the adhesive sealant gets placed on, these two panels get pushed together and really all the adhesive sealant gets pushed down. It is now one solid, very strong panel, and then a lot of weight was added to the top of it, including the spare tire and the spare tire carrier, which is being built, and more to come on that soon, and also some of the extrusions and the other pieces of internal extrusions for the cabinet framing and so forth on top of it. So it really weighs it down and gets it compressed. And here is the finished panel or composite panel with the two fiberglass sheets on each side of the insulative core. And then of course this all now needs to match up from being cut down to fill in the actual voids where the garage door openings are, and also the trimmed out panel pieces that hold all the seals and everything, which I will go over more shortly on how I do all that in my next video. I've double, tripled, quadruple checked all my measurements of the garage doors. They're down to the 1/16 of an inch. Measure them as well as I could. There's a little bit of variability because sometimes it'll vary by as much as a 1/16 of an inch on the long spans from the width, to the bottom, and that's over almost a 4-foot span. So they're pretty darn straight, right? Very straight, very much 90-degree angles, but still they can be slightly off. So I have to count for that. Also, there's a little bit of an angle in the extrusion itself, or the platform that it rides on. Sometimes they're not perfectly level. They tilt up ever so slightly, and that's actually was intentional to make sure any water it gets in there is going to shed out. But I have to count for that as well. So I can't just measure right to the outside edge. I have to also measure to the inside edge, and there could be that difference of about 1/16 of an inch as well to also have to count for. I've got my panel here. It should be pretty uniform thickness so that the extrusions go on all the way around. But I'll find it out once I cut these down, this whole entire panel down, cut them down to the two doors. I've got to lay out the two doors on here. So I really count for my straightest edges here all the way around and utilize those for my longer edges, because these edges should be square and straight. I'll check that and so for make sure that they are. But I've got to do that. I've got to cut this whole thing down. I've got a bit of work to do in doing all that. And so once I get these two garage doors laid out on this one big sheet here, then I'm going to of course get them exactly dimensioned, and it's going to be really hard because I have to get them exactly dimensioned, not only to a 1/16 of an inch of precision, which is really called a millimeter or two, but also the lines drawn to that degree, and make sure that they're all square to each other, that drawn down. But then of course I got to cut them to that. And so once I get them drawn out and everything else, I'll check my measurements again, make sure that everything lines up, they all look right. And then before I do the cuts, because this one panel right here is expensive. Sheet of the insulation in the middle here, this rigid insulation, wasn't expensive. I want to say that was like $40 or $50, so that was reasonable. But the two sheets of fiberglass, when adding those up, I want to say that's probably another $500 to $600. I've got here two different thicknesses to basically sandwich together to make the exact thickness that the inside of the extrusions that I have are. And so, and of course the glue adds a little bit more. I had used more glue than I had intended, and I had intended to do a spray adhesive, which I wish I had done. It would have been a little bit harder to place these pieces on there, get them perfectly square with the spray adhesive, because it really would have stuck as soon as I get them on. But I think I could have had done that. The challenge was I couldn't use spray adhesive because by the time I got around to gluing these up, when I did, they were inside the garage. It was the only flat place I could do. You can see these sawhorses, they're not flat. This panel is not perfectly flat. That's really because the rigid foam is not flat. The rigid foam, the best sheet I could get, has a little bit of a bow to it. It's not going to matter over once I get this cut down to two garage doors, but on the sawhorse and everything else, I just realized I can't get it perfectly flat. Laying these fiberglass down on the sawhorses, they're going to undulate with the sawhorses, and so I'm not going to get a flat sheet, I'm not going to get a flat glue, I'm not going to get a perfect adhesion across. I could have put on the ground here.
would have had to do a whole lot of protection around it for the spray adhesive, and it was outside when it was getting cooler out. So in order to get the best adhesion and everything else, I put it in the garage, put it on one square garage floor panel. I figured that was perfectly flat, that one square garage panel, so it didn't overlap onto another, across the seam onto another garage panel. So that way I could really get these glued down. So I had to use, instead inside of a spray adhesive sealant, and that added thickness. And so now they're just probably ever so slightly, just a little bit on the thicker side, but there is going to have to be sealant in there and some room for that sealant. So I'm hoping it all works out. I've got plenty of surface area for the glue and everything to bond to. Really strong surface of basically the same material, a fiberglass reinforced plastic to a fiberglass reinforced plastic. So I got really good adhesive sealants that'll glue those together well. All this is outdoor rated. It's all really tough. This stuff is practically bulletproof in its thickness. You know, it is durable. I know it's going to be a strong garage door. It's going to be a little bit heavier than I want it to be, and I've got to account for the thickness of the hinge. And I haven't nailed down exactly which hinge I'm going to use. I'm debating between two different stainless hinges, and each have a slightly different thickness. Obviously, that throws off the measurement on the bottom, so I'm going to count for one of those. I got to make that decision, and then also my seals all the way around on the sides and the insides of this. So I'm hoping it gets all right, because if I don't, I've got to rebuild up some new panels at a great expense to do that and cut it all back down again and repeat this. And of course, now we're starting to get into cooler weather. It'll soon get too cold to actually do these adhesive sealants and stuff outside. So I'll have to do it all inside, which is fine, but it just means I have to make space for it and everything else, which gets challenging doing these projects. There's a lot of stuff everywhere. So I got to get these cut perfectly. A lot of little things to think about. So I can get these drawn out, cleaned up first, so I can get some good clean drawings on them and get them cut. Okay, so what I've been doing is putting triangles up against the edges here to get my straight edges. Anyways, I'm using my triangles. I got a bigger one over here, and also a woodworking square, and then also a woodworking ruler over here. And so I'm using all the various tools that I can to try to get everything perfectly squared and lined up relative to the top of the sheet. And also I have to try to get square in this center cut here. And so it does make a lot more complication of trying to get that center cut perfectly square. But I think I've got everything pretty well lined up and good to go here. If I do, and I have a straight line then between these last two lines here, that means that if I line up this line here, or these lines, and this is really hard to see when I got the ruler on one side because of the sun and the shadow, plus this ruler is so hot, I can only hold it for a few seconds. And so these should line up, and they don't. I am off by a hair, and so I got to figure out why that is. I got to recheck my dimensions here in all these and see why I'm off in this middle point. This middle joint is really key, my little cutout notch here. So you got to figure that out. There's a lot going on here to figure all this out.
Boy, it'd be really great to be able to just plug in all these dimensions into a computer and have a CNC cut this, wouldn't it?
Ooh, okay. What I did is I figured out what my problem was. What I'm doing is I'm taking my dimensions of my opening. I'm subtracting a space for the gap at the bottom and the sides, but not the top. I'm subtracting a distance for the thickness of the hinge at the top when it's closed position. And then I'm also adding in everywhere around the thickness of the extrusion as well, because I have to add that on. So this is the top. I add the thickness of the hinge to the thickness of the extrusion at the top, and then add the thickness of the extrusion at the bottom and my gap at the bottom that I need to make sure I have a clear opening. It's not going to rub and everything else. Got a little room in there for the seals and stuff and some thermal expansion. Even though it's all the same materials, they should all expand the same, but just allow for all that. But not too much of a gap that I don't let wind and water and dirt and stuff like that. It minimizes the amount that can get in. So that's what I'm accounting for. The notch out here is where it gets really tricky, because in the notch out here, I'm still subtracting my width of my extrusion and the gap, but then I realize I actually don't have to do that in the notch out here because I've already counted for it on the bigger dimensions, not the smaller dimensions. And so smaller dimensions just simply move that in, but the gap in the extrusion is already accounted for in the bigger dimension, the wider dimension or taller dimension. So I had initially accounted for that gap in those, and I was like, this isn't adding up. And I was figuring out, and then I realized, okay, it's not adding up, and here's why. And then once I drew it out, it all kind of came really clear to me. So I removed the
added gap and extrusion from one dimension but not the other, and then it of course became crystal clear. So now I've got dimensions out. I can double check all these, make sure they're right. Once they're all right, I'll go and lay out my next one. And it's really tough to get these exact perfect straight lines. For example, if I use a triangle like this, it's got that really big bottom edge or base here. When I put that up against here, so if the foam sticks out a little bit, like here it does about a 1/16 of an inch, then it makes, of course, this angle off by a little bit because that foam's sticking out and it's not perfectly straight. Particularly with the foil, it creates like sometimes a little wavy of an edge. And so it makes this not straight. So I've had to adjust for that by using my T-square and getting it just on the fiberglass and make sure it's only on the fiberglass and above the foam. So that's not taking any effect on my cuts here. So a little bit of a learning lesson how I'm dealing with this, but I think I've got it right. Again, I'm going to check my dimensions. Everything looks right. If everything looks right, I'm going to go and do the next one, draw it out, double check everything, triple check it, quadruple check it again before I then go and set up to do my cuts. Make the cuts, do my of one panel, do a test fit, and hope it's right. Whew.
And so I went ahead and laid up the other door and did the measurements in multiple different ways and also with different measuring devices to make sure that not only were my lines straight, but also that my measurements were all accurate and correct for each of the measurements to make sure that these doors are perfectly parallel with the cut openings and also, of course, the right dimensions to match the cut openings.
Okay, this is pretty challenging. Challenging in a couple of respects. One is I have both of my doors out here. I have my passenger side, my driver's side, and of course I was trying to be very careful to make sure I'm not looking at one dimension for one door while I'm drawing the other, which is what I did for this very last dimension. I looked at the wrong dimension because they're, just above each other. And so I was off by 1/4 of an inch on one of these lines. I was like, why can that be? And then of course I figured out it was because I was looking at the wrong door. So I fixed that, trying to get all these lines perfectly straight and all lined up, particularly in this jog here in the corner is really challenging, but did my best. I laid out the door in a way, each door, which I thought would work best with the way these fiberglass sheets come with the foam and the way they made up to it. So thinking about how I'm going to screw in my hinge mounts. Getting these done, I think I've got them lined out right. I think it's time to cut. I can barely even touch anything on this anymore. This panel is so high, I can barely keep my hands on it. The rulers and so forth are getting so hot, I can't even keep my fingers on them. And it's very difficult to see because of the sun's angle, the shadows that the rulers create. I can't really see the lines, and of course I can line them up one way to work with the sun, but then the other direction when I'm getting these 90s down here doesn't work. So it's challenging, and that's hot. All right, time to get cut and get everything on my safety gear, get everything queued up, and hope it goes really well and right, and hopefully I can go all the way through this entire panel in one shot. So I don't have to try to line up a top and a bottom cut, and so I get all the way through, and it'll be clean and clean as can be as far as the cuts go. And then I'll cut one, give it a try, and see how she comes out. Let's do this.
And yep, these cuts generally start with a hole. And of course that hole is there to make sure not only is there a stress relief in these inside corners, but also a way to be able to get the saw blades all the way up into those inside corners. And of course those will be completely enclosed within the extrusions, so those holes are just big enough to do that. But I'm also trying to plunge the saw in here, as you can see, to make sure I'm not wasting a lot of this material that I might be able to reuse for some other purpose, and then pulling in the jigsaw just where necessary to really bring in these tight little cuts. And after finishing the first panel, it's so exciting to get on with the second panel and get these two things cut down. And of course, what I'm doing here is using a circular saw to cut the straight, long lines as much as possible. That is also armed with a blade specifically made for cutting this fiberglass and also a dust extractor to remove most of those particulate matter. But you can still see there's a lot coming off the saw, which is why I'm wearing a respirator to make sure I'm staying safe. And then, of course, also a little bit of help to hold those edges up straight and flat while I cut them, and then of course one more stress relief for the corner cut. And then once that's all done, I take a belt sander around the edges so they're nice and roughed up for a good glue adhesion for the protrusions that will be glued onto those edges.
It's another very stressful part of the project here, in that I have exactly the right amount of protrusions to enwrap all the garage doors, the two very large garage doors. And that is it, only enough. Every cut must be absolutely perfect. And it's all these angled cuts, and they all have to go together perfectly. And I'm also down to pretty much the last day before we get some rain and some cold weather, and so I can't do this outside, and there's a lot of dust, so I do not want to do it inside. Let me show you. Okay, just give you an idea of just kind of how challenging this is. So like some of these cuts have to be, you know, angled such as this, right, in order to go together. And they also don't get shortened. These two pieces here don't get shortened based on the gap in between, whereas all the others do. And so that's something I have to think about. So like this one here is a vertical piece, and I'm going to have a little bit of a gap at the top for the hinge and a gap at the bottom to make sure the door is not rubbing against the opening. And so I've got to cut that a little bit short. And the same with like that piece there. But the top piece doesn't, well, it does get a little bit shortened as well, but then these ones don't. And of course, these ones are like a window box frame, and these ones are mirrored cuts. And so I have to think about all that stuff. And of course, each door is slightly different. And like I said, I've just enough protrusion, so I have to piece everything together and get everything cut just right. And of course, I'm measuring with, you know, pretty crude instruments here. Tape measure, pencil, 5-degree angle. So crude, and you can see, or hear maybe, it's getting windy. The sun is going down, as you can see by the shadows on my face, and then the storm is coming in, and so I've got rain and cold weather coming in. So I've got to basically get all this done and everything inside, all my equipment here and stuff inside, and then of course start attaching my hinges and these protrusions onto the hinges and drill the holes for the hinges and rivet those in, and then start gluing up the doors onto those. So anyways, we got a few things to do. Let me show you my last cut here. Hope I'm down on my last cut. If I get everything right, let's do it. Okay, I'm going to show you this last cut, but I'm going to go ahead and give you a forewarning. My suggestion is don't do it this way. It's actually pretty dangerous. I am very conscious of where my hands are, my fingers, my thumb, and yet I have to get really close, both my face and my arms and my hands and my fingers, to the blade and all the dust that's coming up. So there's a lot of danger to all that. So I'm just going to say, like, if you can find a better way to do this, great. I am limited by the tools I have, and so I've got to do it the way with the tools I have. I'm not going out and buying a bunch of new tools unless for some reason it made my job significantly safer or easier. But I'm down. I think I can pretty much. I've been okay, but I just want to forewarn you about that. The other thing is, I want to also mention, is I am wearing full face protection, dust filtration, hearing protection, gloves, because this fiberglass dust gets on your hands and things and it makes it itch. And so I do go in and take a good shower afterwards. I make sure I take all my clothes off really out in the garage, so I'm not tracking that dust inside. And I don't shake myself off inside the house. I'm not breathing that dust inside the house. Try to keep it all outside. I vacuum everything down pretty regularly here, including even the ground, and just to keep this dust from spreading around. And just some things to think about. So it's going to look pretty scary, perhaps, and dusty, and it is. And so that's why I'm not really keen on showing you this, but I'm going to show you this last one, so hope everything goes right. Try and knock all my dust off so I'm not getting inside the mask. Try to always put my mask down so that dust doesn't get inside of it. I blow it out, shake me off. Then I put my hearing protection on, make sure I don't have my mask straps over my ears. Wipe my hands and arms off once again. Any debris that might be on there. Gloves, which I've already shaken out. Here once again. Here we go.
And I have to get really close to make sure that the saw blade is lined up with exactly where I need it on the cut. And so that's why I'm down on my knees and down low there and getting my face close to it before I turn the saw blade on. And my hand, even while it looks very close to that saw blade, it is in a safe place. It is several inches away from the saw blade. Thumb is tucked in. And then, of course, afterwards, I go ahead and pat myself off and get all that dust off me.
Let's take our piece. So I got it marked in there, passenger side. All goes well. See, it should fit right in, and you can see it does. It takes their pieces to get out. There's going to be a little bit of a order of operations to get these in, but it looks pretty perfect. So we'll find out tomorrow. We'll go to install these in there. It'll be more like that. And these are not all perfectly fit right now, so I've got to do a couple things to get them all fit in, but they should work. So let's go get these things installed tomorrow, glued in place. Right now I'm going to get the final hinge bolted onto the camper, or riveted onto the camper, and get all these pieces inside before we lose sunlight, and before the rain and the cold weather and everything comes, and so I can be all ready to work on this inside the shop / garage. Got to build up these garage doors. It's a lot of work to do, and there's a lot of steps, no doubt. And you can see from the protrusions I had, these were all 4-foot sections. This is all that I have left right here. That's it. And once you make a 45-degree angle on these, because these are 4 inches basically on their total thickness, meaning from the bottom to the top there, you lose 4 inches every time you make a cut. So fortunately, I calculated out just right, and I've just enough. And I didn't make any mistakes, I don't think. If I have to recut one because it's short, then I'm screwed. If I have to cut a little bit off because they're a little bit long, then I'm okay. And there's a very good possibility that I tried to cut all of them long, but there is a bit of an issue too, in that sometimes like these, depends on where you cut them, and any of these really, if I cut on which side of the line, particularly these ones are a little more tricky, because I may cut on the opposite side of the line because they're different than all the rest. So I'm hoping everything lines up and connects up just fine. We'll find out.
Well, it turns out that they did. They all did line up and connect up just fine, and these garage doors actually turned out perfect and beautiful with exactly the right gaps where they need it. And now the next video I'm going to show you that, as well as also the framing out of these openings, and also how I attach the hinges and why I did it that way. So thank you so much for watching. Thank you for sharing and subscribing, and certainly there's a lot more to come. This is video number 83, and there's probably a few dozen more videos to come on the finishing and the building out of the cabinet framing on the inside of this camper, also building out, of course, the spare tire carrier, installing the really big electrical system, finishing up some of the plumbing, and of course also this electrically sliding dining table that actually supports me all the way cantilevered out, which is pretty amazing and cool to watch. Coming up all in my future videos. So thank you for watching, subscribing, certainly keep yourself safe, and do share with others, and by all means ask me any questions.
Today we're going to make some composite panels, and these are to actually make the garage doors, the garage opening, the gear garage opening doors.